Let's start with our star. And we find the last 24 hours was mostly quiet. The massive sunspot group departing on the north was quiet again, but the new spots incoming on the south were a bit more active. Solar wind and geomagnetic conditions were quiet, and so as we will see in 131 angstroms, the blue overlay, it was the incoming spots on the south that were more active. The simple magnetic setup of the departing sunspot on the north has continued to allow it to calmly lumber across heliographic longitudes without firing any significant eruptions. While sunspot size is definitively a factor in the power of eruptions, the current look indicates why complex magnetism, even in a smaller group, can trump larger umbral size in any given situation. We'll have eyes open. Top earthquake of the day happened just a bit ago in the Southwest Pacific. 6.9 struck near Tonga, and luckily it was very deep. Surface shaking minimalized by that depth. Folks, a fantastic layman article is out about the paper we covered last week detailing how they have underestimated volcanic impact potential on climate. If the papers are generally too complex or just plain boring for you, I get it. This article is written for everyone. It is linked below, and of course it brings back to mind the recent story about what I've been saying is the most worrying volcano on Earth, Campi Flegrei in Italy, which they now admit is becoming scary as the crust weakens above it. Top article today is an excellent review of the risks of space weather events. They go over the main principles from a broad standpoint, including graphics for perspective and infographics that detail some of the important staged impact and effect zones in terms of critical infrastructure. One of their most telling sections covered the Carrington event superflare back in 1859, how the CME took less than a day to arrive, compared to most which take 2 to 4 days, and how it set fires and electrocuted operators in one of the few electrified sectors that existed back then. They make the important claim that it's not a matter of if, but when it happens again. Solar cycles are known, and those include the recurrence of these major blasts, with the key difference being that we are now in an electro-dependent society. Nearly everything we rely on to sustain 7 billion people on the planet is at risk when the sun unleashes again, something we are in the red zone for and awaiting in the coming years, leaving the world without power for months at least, and everyone to fend for themselves. But, as many observers know, it is likely to be even worse than this. In 1859, it was a flare in the X30 to X50 range and took only 17 hours to arrive, but the magnetic field was strong back then. When it happens again, it's likely to be the millennial flare, possibly up to X1000, but definitely over X100. It may only take an hour or two to arrive, leaving us without time to prepare at all, and this time, the stronger flare would take aim at a planet with a weakening magnetic field. This is the critical point we made in yesterday's video. We've got unprecedented vulnerability as a species, and the clock is ticking.